So up to this point, we set up a visual model and then show how to come up with the decision rule for the current consumption and the future consumption. And then we find the current consumption and the future consumption that maximize the utility. Then what we want to do is that we also want to do the comparative statistics, that is when something got changed, what will got changed. So then as we learned before, we say that when the initial bills, current income, future income, and the real interest rate got changed, it will affect the consumption and saving decisions. In here, what we want to do is that we want to see how's the impact of this change on the consumption and saving decisions from the model's perspective. So to begin with, we want to look at the first type of the changes. As we mentioned earlier, we said that there are two types of changes. One is changes to the initial bills, current income, and future income. For these three types of change, all of them will increase the present value of the lifetime resources. So then in the problem that we solve, we will clearly see that when we increase the initial bills, the current income and the future income, it will only affect the intertemporal budget constraint, and then it will increase the YT plus 1, and adding in the A0. So then, given such a change, it will shift the intertemporal budget constraints to the right. So then in graph, what we will see is that this is the original consumption bundle we choose. Once we have the increase in the initial wealth, current income, and the future income, then we are going to have the line, the intertemporal budget line, that parallel shifts to the right. So then the outcome will be that we will tangent on an indifference curve that is to the upper right of the original indifference curve. And then so what we end up to have is that we are going to have more consumption in the first period and also in the second period. And then we will be able to infer what is the amount of the savings. Now let's move on to look at when the real interest rate got changed, how will that affect the results? It turned out that when we look at the maximization problem, we will see that the changes in the interest rate will affect the intertemporal budget constraint. It not only affects the slope of the line, but it also affects the total present value of the lifetime resources. So then that the answer to this problem is these two equations below, that is CT equals a half of the present value of the lifetime resources, and CT plus 1 equals a half of the present value of the lifetime resources multiplied by 1 plus R. So then again in here you will see that the changes in the R will affect the current consumption by affecting the present value of the lifetime resources. But for CT plus 1, the changes in the R not only affects the present value of the lifetime resources, but it also affects the inverse of the relative price of the future consumption relative to the current consumption. So then how will the changes in the real interest rate affect the graphical result that we had earlier? Given that the changes in the real interest rate will not affect the shape, the form of the utility function and the indifference curve. Therefore, let me drop it for the time being when I show the graph. So then what I want to do in here is to highlight 3 points on top of this intertemporal budget constraint. The first point I want to highlight is the intersect of the intertemporal budget constraint on the vertical axis. In here, we know that the intersect represents the point where the individual chooses to consume nothing in the current period, but choose to consume all the resources that they have in their lifetime in the second period. So in here, the second period consumption will equal YT multiplied by 1 plus R plus YT plus 1. The second point I want to highlight is the point where the intertemporal budget constraint intersect the horizontal axis. In here, we see that when we choose to consume nothing in the second period, then in the first period, we are going to consume the present value of the lifetime resources. The third point I want to highlight is the endowment point. That is, if you choose your consumption bundle at this point, then you are somehow consume the first period income in the first period and the second period income for the second period. Because of that, when the real interest rate got changed, the changes in the R will not affect you at all if you consume at the endowment. However, the changes in the R will decrease the present value of the lifetime resources. Therefore, the intercept of the intertemporal budget constraint on the x-axis will move toward the left. On the contrary, for the point that the intertemporal budget constraint intercepts on the vertical axis, that when the real interest rate got increased, it will pushes up the point. Therefore, given that there is a point that when R increases, it is fixed, and when the R increases, that the intersect on the vertical axis is much higher, and for the intersect on the horizontal axis, it becomes smaller. Therefore, it will associate with the tilt of the line that is fixed at the endowments. So from the discussion above, we know that when the real interest rate got increased, the intertemporal budget constraint will tilt and become steeper. Then, based on this key point, we want to identify how well the decision for consumption and saving got changed when real interest rate got increased. So to answer this question, we need to put the indifference curve back and see how will that affect the result. But then we will say, hey, wait a minute. When we want to decide how will the changes in the real interest rate impact on the consumption and saving decisions, we know that when the real interest rate got changed, then the impact on the lender and borrower differ. So then it will determine where we will put the tangent of the indifference curve on the original budget line. If it is to the left of the endowment, we know that that individual is a lender. If it is to the right of the endowment, then we know that individual is a borrower. So then how to identify whether an individual is a borrower or lender based on the equation we have and the answer we got up to this point. So to answer this question, let's examine what we already have in hand. What we know is that for an individual who is a borrower, then it means that that individual will consume more than what they receive in the first period. On the other hand, if an individual is a lender, then we know that individual will consume less than the income they have in hand in the first period. Therefore, what we want to do first is we want to compare the income versus the consumption in the first period such that we will be able to identify who is the lender and who is the borrower. So it turned out that we can say the saving in the first period is the income in the first period minus the consumption in the first period. Therefore, we can continue to keep the YT and include the answer for CT in here, given that from the solution we got above, the CT equals a half of the YT plus a half of the present value of the future income. Therefore, this equation tells us the savings equal a half of the current income minus the present value of the future income. So for an individual to be a lender, we know that the saving need to be positive. So it implies that the YT need to be greater than YT plus 1 over 1 plus R. On the contrary, if an individual is the borrower, then we know the saving need to be negative. Therefore, we know from the equation, if an individual is the borrower, then the current income need to be less than the present value of the future income. So then from this result, we can infer that if the current income is much higher than the future income, then it's more likely the current income is greater than the present value of the future income. Then the individual will for sure be a lender. If an individual has the current income much less than the future income, then for sure the individual must be a borrower. So then now we already know how to come up with the lender and borrower from the graph, because now we know if the tangent point of the indifference curve and the intertemporal budget constraints is to the very left of the endowment, then the individual should be the lender. On the contrary, if the point that the indifference curve tangent on the intertemporal budget constraint is to the very right of the endowment, then we for sure know that that individual is a borrower. So before we move on to do the plottings, I want to remind you about the income effect and the substitution effect for borrower and lender when the real interest rate got increased. So when the real interest rate got increased, the income effect on the borrower causes the consumption in both periods to fall, and the substitution effect causes the current consumption to fall, but the future consumption to increase. And the substitution effect is the same for the borrower and lender. For the lender, the income effect causes the consumption in both periods to increase. So then for a borrower, we know for sure that when the real interest rate got increased, the consumption in the first period should fall, because both income effect and the substitution effect indicates that the consumption in the first period should fall. Given that we know when the real interest rate got increased, it implies that the first period income remained the same. Therefore, we know that the saving should increase for a borrower. However, even though the borrower for sure saved more in the first period, it doesn't mean that the borrower will be able to consume more in the second period. That is because when the borrower saves more, it implies that the borrower will borrow less. But when the borrower borrows less, it doesn't mean that the consumption in the second period for sure will be increased, because the amount they borrow need to multiply by the R, and that will be the total amount they pay back in the second period will be the amount they borrow multiplied by 1 plus R. So then when the increase of the R is large, then it is still possible that even though the borrower chooses to save more in the first period, it doesn't mean that the amount they can pay back can be reduced. For a lender, it is the opposite. Somehow in the first period consumption, the impact will be different for income effect and the substitution effect. Therefore, it is not that clear in what direction the saving will change when the R increase for a lender. However, we know for sure as the lender, when the real interest rate got increased, their second period's consumption will be able to increase, because when the real interest rate got increased, they got more resources for sure. So now let's begin to draw the graph to illustrate how to use the intertemporal budget constraint and the indifference curve to come up with the consumption decisions rules. So for this particular example, we have the household that have the indifference curve look like this. And then so if we have a budget constraint of this type with endowment at the red dot, then we are going to be able to identify this individual is a borrower. Then when there is a real interest rate increase, then it will tilt the intertemporal budget constraint, and the tilting point that is fixed is the red dot. So then that's what we are going to get in here. So then based on this graph, we know that the individual will no longer be able to choose the consumption bundle at the original point. In fact, that the indifference curve need to shift inward, and then tangent on the point which first period consumption that becomes lower and the second period consumption that becomes lower as well. Therefore, we know for this particular case, the consumption in both periods should decrease, given that the current period income remain the same, so we know saving increase. So then if we look at the income effect and the substitution effect, we will see that for this particular case, the income effect dominates the substitution effect. So this is an example for a borrower. Now let's take a look at another example. So as you can see in this graph, we have the individual here that has the very similar indifference curve and intertemporal budget constraint and endowment as the first individual. However, for this case, we have the R that increased much more. So then we are going to see a tilt of the intertemporal budget constraint that becomes more dramatic. Because of that, we will be able to push the indifference curve in a way that it tangents at the point that the consumption in the first period also falls, but then the consumption in the second period somehow got increased. So then for this particular example, given that the first period income is the same, so we have saving that is also increased. So then let's look at the income effect and the substitution effect. Given that in the second period, the consumption increased instead of decreased, so we know for this case, the substitution effect dominates the income effect. So as you can see in here, when the R increase is more dramatic, which makes the tilt of the intertemporal budget constraint more dramatic than the substitution effect, which implies that the future consumption becomes cheaper and people want to save more today to increase their future consumption, the effect is stronger under this case. So then we are going to have the substitution effect dominates the income effect and have a different outcome. That is, the borrower can have the second period consumption that becomes higher. Now let's look at another case. In this case, we have the indifference curve tangent to the very left of the endowment point on the intertemporal budget constraint. Therefore, we know this individual is a lender. So then when the real interest rate got increased, then it will tilt the intertemporal budget constraint, which is fixed at the endowment. And then we will see that for this individual, it will end up to have a higher second period consumption and also the first period consumption. Therefore, given that the income remained the same for the first period, so we know this individual's saving should fall. Then we look at the income effect and the substitution effect. You will see that for this particular case, the income effect dominates the substitution effect. Now let's see if it's possible for a lender that the substitution effect can dominate the income effect. So now let me draw another graph. So then in here, we also have the individual that is a lender. But then in this case, the tangent point is closer to the endowment. And then now with the interest in the real interest rate, we tilt the intertemporal budget constraint, and then we shift the indifference curve outward. And then in this case, we are going to have a higher second period consumption as well, but then we have a lower first period consumption. So then given that the first period income remains the same, so we know for this case, the saving should increase. So then if we look at the income effect and the substitution effect again, we will see that in this case, the substitution effect somehow dominates the income effect. Therefore, for a lender, we know that it's also true that it's possible that the income effect that dominates the substitution effect, and it is also possible that the substitution effect can dominate the income effect. But regardless of either cases, we know for sure for a lender, the second period consumption will increase, in either way. But for the savings, for some cases, that it's possible that the saving falls because the income effect dominates. For some cases, the saving should increase when the substitution effect dominates. So then, if you compare the graph of these two, you will find that the tilt of the line in both cases are quite similar, but the difference is for the first lender is an individual that saves much more than the second lender. Therefore, when there is an increase in the real interest rate, the income effect will dominate the substitution effect because that individual now enjoys much more resources than the second lender. But for the second lender, given that individual save a little bit less than the first lender, so then resources that the individual can enjoy due to the increase in the real interest rate is not that much. Therefore, the substitution effect dominates. So in here, I show 4 cases, 2 for lender and 2 for borrower. For both of them, they can have either the income effect dominates or the substitution effect dominates. And in graph, they will be different. When we are solving this problem using equations, then we don't need to think about that much. But once we come up with the answers in numbers, then we will be able to infer which case it turned out to be. So here we complete the discussion related to the comparative status about when some factor got changed, that is the changes in the initial wealth, changes in the first period's income, the second period income, and there is a changes in the real interest rate, and how will that affect the consumption and saving decisions.